October 18, 2025. Harvard astrophysicist Avi Loeb just published new images that are making the scientific community very uncomfortable. An interstellar visitor, older than our sun, is doing something that should be physically impossible. 159 separate telescope exposures, 50 seconds each, all showing the same thing, a jet of material pointing toward the sun. Professor Brian Cox, one of the world's most respected physicists, calls this story remarkable. Avi Loeb, former chair of Harvard's astronomy department, just published a list of 8 anomalies that don't match any known comet in history. Loeb's exact words from October 19th. Comet experts are insisting that 3I Atlas is a familiar comet while ignoring this anomaly. It's as shocking as photographing an animal in your backyard which your family identifies as a common street cat, while the image shows a tail coming out of the animal's forehead. Normal comets have tails pushed away from the sun by solar radiation and solar wind. It's basic physics. It's unavoidable. 3I Atlas, multiple telescopes, Hubble, Keck, and now the 2-meter twin telescope all confirm it. The tail points the wrong direction. Brian Cox, speaking to the BBC, there's an estimate it might have formed 7.5 billion years ago, before the Earth and the Sun had formed, and we're taking photographs of interstellar comets from the surface of other planets in about 400 years. This isn't just about a weird comet. This is about an object that traveled through the Milky Way for billions of years. An object that scientists photographed from Mars' orbit. An object with chemical signatures that only exist in industrial manufacturing here on Earth. And an object that, according to Avi Loeb's calculations, has 8 separate anomalies that shouldn't exist together. In the next 15 minutes, I'm going to show you why the October 19th images change everything, what Brian Cox finds so remarkable about humanity's achievement, why Avi Loeb is challenging the entire scientific establishment, the industrial chemical signature found 2.75 astronomical units from the sun, and why this 7.5 billion-year-old visitor might rewrite what we think we know about interstellar objects. Avi Loeb ends his October 18th article with a warning to Hopefully, these AI systems will not be too indoctrinated by the club of This is Let's start with what we know for certain. On July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System, ATLAS for short, spotted an object moving through our solar system. But this wasn't just any object. Its eccentricity, a measure of how elliptical an orbit is, came in at 6.1 to 6.2. Here's why that matters. An eccentricity of exactly 1.0 means an object is moving at escape velocity. Anything above 1.0 means it's not bound to our solar system. 6.1 means this object came from outside our solar system. From another star. From interstellar space, that letter I in its name stands for interstellar. 3I Atlas is only the 3rd interstellar object ever confirmed in human history. In 2017, Oumuamua was designated 1I. In 2019, 2I Borisov. And now in 2025, 3I Atlas. According to Professor Brian Cox, physicist, science communicator, and former keyboard player for the band D-Ream, 3I Atlas may have formed 7.5 billion years ago. Think about that. The Sun is 4.6 billion years old. Earth is 4.5 billion years old. This object existed for 3 billion years before our solar system even formed. Brian Cox put it perfectly in a BBC interview. It was made before the Earth and the Sun had formed out of a cloud of dust. And it's been on its journey across the Milky Way galaxy. It's moving at speeds that break records for objects of this type. We're talking about the fastest interstellar visitor ever detected. 3I Atlas is passing through our solar system right now. It swung past Mars in October 2025 and will leave our solar system forever within months. We have one shot to study this object before it disappears back into the void for potentially millions or billions of years. NASA, ESA, and observatories worldwide are throwing everything they have at it. The European Space Agency's ExoMars Trace Gas Orbiter captured images of it from Mars orbit. The Jupiter Icy Moons Explorer spacecraft will photograph it near Jupiter. Brian Cox again. It's only 400 years ago that we were arguing about whether the Earth went around the Sun. Now we've sent spacecraft to the planets and we're taking photographs of interstellar comets from the surface of other planets. Think about that. 400 years ago, we argued about heliocentrism. Today, we photograph ancient visitors from other star systems from Mars. But here's where things get weird. On July 21, 2025, the Hubble Space Telescope captured an image of 3I Atlas, and scientists immediately noticed something wrong. The tail was pointing toward the sun. Avi Loeb describes this perfectly. Realizing this is as shocking as photographing an animal in your backyard which your family members identify as a common street cat, while the image shows a tail coming out of the animal's forehead. Let me explain why this is impossible according to everything we know about comets. When a comet approaches the sun, solar radiation heats its surface. Ice sublimates, turns directly from solid to gas. This gas and dust gets blown away from the sun by solar radiation pressure and solar wind. That's why comet tails always point away from the sun. It's physics. It's unavoidable. The most effective scattering particles are about 0.5 micrometers, roughly the wavelength of visible light. If 3I Atlas had normal dust particles, they would definitely be pushed away from the sun. But that's not what we're seeing. On August 2, 2025, the 2-meter twin telescope in the Canary Islands confirmed it. 159 exposures, 50 seconds each. Clear evidence of a jet pointed toward the sun, an anti-tail extending about 6,000 kilometers from the nucleus. Then, on August 24, 2025, the Keck 2 telescope in Hawaii captured detailed images using their cosmic web imager. Same result, anti-tail pointing toward the sun. Avi Loeb and Eric Cato published a paper analyzing this phenomenon. They state this phenomenon, observed at a distance of 3.8 astronomical units from the sun, is possibly observed for the first time in 3I Atlas. Now, before we jump to conclusions, anti-tails can occur naturally. They're rare, but they exist. There are two types. Type 1 is an optical illusion. When Earth's position relative to the comet and sun creates a viewing angle that looks like an anti-tail, but isn't actually one. Type 2 is large grain ejection. When large dust particles get ejected from the comet's sunlit side but don't get pushed away immediately because they're too heavy. Comet Bernardinelli Bernstein showed something similar in 2021, so anti-tails can be natural. But here's the problem. Most naturally occurring anti-tails are weak and short-lived. 3I Atlas's anti-tail is prominent, persistent, and extends 6,000 kilometers. And that's just anomaly number 1, because when astronomers looked closer at what was in that anti-tail, things got even stranger. The Keck Observatory didn't just photograph 3I Atlas. They analyzed its spectrum, the specific wavelengths of light it emits. This tells us what chemicals are present in the gas plume around the comet. And what they found shouldn't exist in nature. The spectrum shows prominent nickel emission. But here's the shocking part. No iron. In a new paper published in October 2025, astronomers W.B. Hugendam and colleagues state, in contrast from all known comets, including the interstellar comet 2I Borisov, the observed spectrum of the gas plume around 3I Atlas shows prominent nickel emission, but no evidence for iron. Why does this matter? Because in nature, nickel and iron always occur together. They're cosmically married. You find one, you find the other. The only time you get nickel without iron is in industrial manufacturing, specifically through something called the carbonyl chemical pathway, a process used to refine nickel in factories through the formation and decomposition of nickel tetracarbonyl, NiCO4. This is how humans make pure nickel alloys industrially. The paper authors postulate that this carbonyl process might be occurring naturally near the nucleus of 3I Atlas. But they also admit this has never been observed in any natural comet before. The Keck images show nickel concentrated within 600 kilometers of the nucleus, while cyanide extends to 840 kilometers. The production rate of nickel relative to cyanide is orders of magnitude above the solar system comet median. Not slightly higher. Orders of magnitude higher. For perspective, normal solar system comets have a low nickel to cyanide ratio. 2I Borisov, the previous interstellar comet, had a higher ratio. 3I Atlas has a ratio orders of magnitude higher than both. Avi Loeb notes, the more data we get about 3I Atlas, the more it looks like an outlier. Here's another mystery. The white light images of 3I Atlas show no evidence of a normal dust tail. Comets are supposed to have dust that scatters sunlight and gets pushed away by solar radiation pressure. But 3I Atlas? The nickel and cyanide emissions are asymmetric with extensions in both the solar and anti-solar directions, but no visible dust tail pointing away from the sun. Avi Loeb, paraphrasing a Jewish Passover song called Dayenu, which means it would have been enough, lists these findings as accumulating evidence. If 3I Atlas had a sunward jet or anti-tail, Dayenu. If 3I Atlas showed a gas plume with nickel but no iron, as found in industrially produced nickel alloys, Dayenu. If 3I Atlas had a nickel to cyanide ratio that is orders of magnitude larger than all known comets, including 2I Borisov, Dayenu. In other words, any one of these would be noteworthy. Together, it's unprecedented, but we're only 2 anomalies in. There are 6 more. Avi Loeb maintains a ranking system he calls the Loeb scale, rating objects by how anomalous they are. 3I Atlas currently ranks 4 out of 10. Here are all 8 anomalies that earn it that ranking. Anomaly number 1, anti-tail pointing toward the sun. We covered this, a 6,000 kilometer sunward jet. Anomaly number 2, nickel without iron, an industrial carbonyl signature never seen naturally. Anomaly number 3, extreme mass. 3I Atlas is approximately 1 million times more massive than Oumuamua and 1,000 times more massive than 2I Borisov. For an interstellar visitor, this is enormous. Anomaly number 4, trajectory alignment. Its trajectory is aligned within 5 degrees of the ecliptic plane, the flat plane where all our solar system's planets orbit. For a random interstellar object, the odds of this alignment are incredibly low. Anomaly number 5, fine-tuned arrival timing. Its arrival time was perfectly tuned to pass within tens of billions of kilometers from Mars, Venus, and Jupiter. In October 2025, it passed just 30 million kilometers from Mars, close enough for the Mars Reconnaissance Orbiter to photograph it. That's suspiciously convenient timing. Anomaly number 6, water deficiency. Normal comets are water-rich. That's their defining characteristic. They're called dirty snowballs for a reason. 3I Atlas, only 4% water by mass. Comet experts predicted it would be water-rich when they first detected it. They were wrong. Anomaly number 7, extreme negative polarization. The way 3I Atlas polarizes light is unprecedented. All known comets, including 2I Borisov, show certain polarization patterns. 3I Atlas shows extreme negative polarization never seen before. Anomaly number 8, the WOW, signal coincidence. This one's wild. In 1977, SETI detected the famous WOW signal, a 72-second radio burst that remains unexplained. The signal came from a specific direction in space near the constellation Sagittarius. Avi Loeb calculated 3I Atlas's trajectory and found it came from a direction within 9 degrees of the WOW signal's origin. Coincidence? Probably, but it adds to the statistical strangeness. Let's be clear, each individual anomaly could have a natural explanation. The anti-tail? Rare but possible. The nickel signature? Maybe a natural carbonyl process. The trajectory? Could be random luck. The WOW signal alignment? Almost certainly coincidence, but all 8 together? That's what's making some scientists uncomfortable and making others very curious. So we have two competing viewpoints in the scientific community. Viewpoint number one, it's just a comet. This is the mainstream position. The majority of astronomers believe 3I Atlas is exactly what it appears to be, an ancient comet from another star system with some unusual properties. Their arguments are as follows. Anti-tails can occur naturally with large grain ejection. Chemical anomalies reflect different stellar formation environments. Statistical coincidences happen. We're pattern-seeking creatures. It shows cometary outgassing and behaves like a comet. Extraordinary claims require extraordinary evidence, and they're right to be skeptical. Science should demand high standards of proof. NASA and SETI have both released statements saying there's no evidence 3I Atlas is artificial. SETI's official response: there is little reason to suspect 3I Atlas is anything other than a natural object. Fair enough. Viewpoint number two. Investigate all possibilities. This is Avi Loeb's position. Avi Loeb's position is not, this is definitely aliens. His position is, we should investigate all possibilities, including artificial origin, rather than dismissing them because they make us uncomfortable. From his articles, the scientific method isn't about what we want to be true. It's about following evidence. Loeb points out that when Oumuamua was discovered with its strange acceleration and elongated shape, the mainstream immediately said it's natural. But they couldn't explain the acceleration without invoking comet outgassing that showed no visible tail. Loeb suggested light sail technology as an alternative hypothesis. He got destroyed by the scientific community, called a publicity seeker, a crackpot, unprofessional. But here's the thing, he's been right before. When everyone said supermassive black holes couldn't form in the early universe, Loeb's papers predicted they could. Years later, JWST confirmed it. When everyone said population 3 stars couldn't be detected, Loeb showed how. Now we're finding candidates. His track record for unconventional but correct predictions is pretty good. The Loeb scale that he created rates objects from 0 to 10. 0 equals definitely natural. 5 equals ambiguous, needs more data. 10 equals definitely artificial. 3I Atlas ranks 4. That's still on the probably natural side, but it's high enough that Loeb argues we should take it seriously. His fundamental argument, objects don't just spontaneously appear from empty space. Either our calculations are wrong, or this object took a journey we don't understand. Here's what both sides agree on. 3I Atlas is genuinely anomalous. More data is needed. We should study it intensively. Science progresses by investigating mysteries. Where they disagree is how much weight to give accumulated anomalies, whether artificial origin deserves investigation, and how to interpret statistical coincidences. Brian Cox's take is perhaps the most balanced. He finds it remarkable not because it's necessarily alien, but because humanity has reached a point where we can photograph billion-year-old visitors from other star systems from Mars' orbit. That alone is extraordinary. So what's next for 3I Atlas? As of this recording, multiple spacecraft and observatories are tracking 3I Atlas as it leaves our solar system. Already completed observations include July 21st, 2025, Hubble Space Telescope imaging. August 2nd, 2025, 2-meter twin telescope imaging. August 24th, 2025, Keck Observatory spectroscopy. And October 2nd, 2025, Mars Reconnaissance Orbiter. High-rise imaging, though the data has not yet been released. Upcoming observations include November 2025, when the Jupiter Icy Moons Explorer spacecraft, JUICE, will photograph it near Jupiter. March 2026 Juno spacecraft observations and ongoing ground-based telescopes worldwide. The high-rise images from Mars' orbit are particularly exciting. They have 3 times better resolution than Hubble or Keck, about 30 kilometers per pixel. When NASA releases that data, we'll see the anti-tail from a side view instead of nearly head-on. This will either confirm it's a natural phenomenon or make it even more mysterious. The Vera C. Rubin Observatory is scheduled to begin operations soon. It will scan the entire visible sky every few nights. Scientists estimate it could detect up to 70 interstellar objects per year. Think about that. We found 3 in all of human history. Soon, we might find 70 per year. If 3-Eye Atlas is representative of typical interstellar visitors, we'll start seeing patterns. If it's an outlier, we'll know that too. Either way, we're entering an era where interstellar archaeology becomes possible. Avi Loeb ends his articles with a pointed message to mainstream astronomers who insist 3-Eye Atlas is just a comet while ignoring its anomalies. He writes, "I leave this question to historians of science. History depends on who writes it." The history of the 21st century will likely be written by AI systems. Hopefully, these AI systems will not be too indoctrinated by the club of unimaginative scientists who ignore the anomalies of 3-Eye Atlas. That's a shot fired directly at his colleagues, but he has a point. Science progresses when we investigate anomalies, not when we explain them away because they're uncomfortable. Loeb's own statement: "There is nothing better than more high-quality data in clarifying the nature of 3-Eye Atlas." Science is fun because it allows us to acquire new knowledge from evidence collected by instruments rather than stories collected by people. Both sides agree on this. Let the data speak. So what is 3-Eye Atlas? The honest answer is we don't know yet. Is it a natural comet with unusual properties? Probably. Is it worth investigating alternative hypotheses? Absolutely. Here's what we know for certain. It's 7.5 billion years old, older than our solar system. It's traveled through the Milky Way for billions of years. It has 8 documented anomalies that don't match known comets. It's leaving our solar system within months. We have one chance to study it before it's gone forever. Brian Cox's perspective deserves the final word here. It's only 400 years ago that we were arguing about whether the Earth went around the Sun. Now we've sent spacecraft to the planets and we're taking photographs of interstellar comets from the surface of other planets. Think about that journey. In 1609, Galileo pointed a telescope at Jupiter and discovered moons, proving not everything orbits Earth. In 2025, we photographed billion-year-old visitors from other star systems from Mars. In 400 years, we went from, does Earth orbit the Sun, to what star system did this ancient visitor come from? Whether 3-Eye Atlas is natural or artificial, its existence proves something profound. The galaxy is full of wanderers, objects that travel between stars, remnants of dead worlds, ancient time capsules from stellar systems that may not exist anymore. And now, for the first time in human history, we can see them. 3-Eye Atlas is out there right now, moving away from us, heading back into the void. In a few months, it'll pass Jupiter. In a few years, it'll leave our solar system. In a few decades, it'll be so far away we'll never see it again. But for this brief moment, this cosmic blink, we shared space with a visitor that's older than our sun. And that is remarkable. Regardless of whether it's a comet or something else, 3-Eye Atlas has taught us that the universe is far stranger than we imagined, and we're finally capable of seeing that strangeness.